Good evening everyone. So today we are going to perform an experiment of measuring flow rate of water flowing through a greenhouse. So the first and foremost, the question arises why using a greenhouse instead of volumetric meter or venturimeter? Because volumetric meter and venturimeter are used to measure flow rate through pipes, which are used at industries or various places. But to measure the flow rate of water through open channels like rivers or canals, we will need the instruments like greenhouse. So V0 is basically an opening through which water flows at certain height, which will measure to calculate the theoretical discharge. So now we will study the components which will be required for performing the experiment. So the first component is obviously the V0. The next component is screw gauge, which will be required to measure the height of water above the crest level. The head of water at crest level will be our reading H1, which is reference reading. Now the water level above the crest level will be measured using screw gauge by sliding it up. So as it is slide it up, it will get to reach like this. Then we will measure the head of water above the crest level using the scale. Here the scale is provided on the voltage. So another component is this baffle. Baffles are used to slow out the turbulence because the water flowing from this pipe will be turbulent flow. The water means the flow will be with vibrations and turbulences. So to reduce the turbulences, this baffle is provided. So here there will be smooth flow rate of water. So the discharge will get by calculating the water flow rate to V0 with the theoretical. To measure the actual discharge of water, we will need to calculate the volume of water flowing through this. So we have provided here a measuring tank in which the volume of water flow rate will be calculated by measuring the cross-section area of the tank, which we will know, and for some time we will start the water flow rate and calculate the head of water which will rise in this. So the cross-section multiplied by the head which will rise in this pipe will be our volume of water flow which flowed through this for a particular time. Please consider this for a particular time. In this experiment we will take 60 seconds. So the volume of water flow rate per unit time will be the actual discharge, which will be less than theoretical discharge due to the losses involved. The water supply will get from a pump, and after performing the reading, after taking one reading, we will take the water from the water tank, measuring tank, to each channels. So as you can see, the water has started flowing to the north. The head will rise above the crest level, and also we will note down the time up to 60 seconds. So the volume of water flow rate can be calculated easily. Now the water flow rate, we will get the theoretical discharge by measuring the head. The formula for theoretical discharge is 8 by 50 into tan theta by 2 into root 2g into h raised to 5 by 2. So for theoretical discharge we will only require the head above the crest level. Now to measure the actual discharge, we will calculate the cross-section area of this tank. For this experiment, the cross-section area of this measuring tank is 50 by 100 centimeters. 50 by 100 centimeters, and also we will calculate the rise in the level of water to get the height of water level rise. So for 60 seconds we will calculate down the time. As you can see, 52 seconds has happened. Now I calculated the time and we will measure the head of water level rise. This has to be done before the when the hook touches this, we will measure the head of water. Before it was 9.3 centimeters and now it is approximately 12.4 centimeters, which is the head of water. 12.4 minus 9.3, that is 3.1 centimeters approximately. So that will be the head required for theoretical discharge. Now for actual discharge, we will measure the. So as you can see, the initial reading of level of water is marked here with pen. This is initial reading, and after 60 seconds, the rise of head of water is this much, as seen. So we will measure this using a scale. It is approximately 7.9 centimeters. So now, therefore, the volume of water flow rate will be 100 into 50 into 7.9 centimeters. So we will get the volume of water which has flowed through the V0. So we will keep this area into final minus initial, that is the volume divided by time, 60 seconds. Therefore, we will get the actual discharge of water. Now, for theoretical discharge, we had the head that was approximately 3.1 centimeters, which we will keep in the formula of theoretical discharge. A plus 15 into tan theta by 2 into root 2g into h raised to 5 by 2, where the head of waterfall, the first reading will be 3.1 centimeters and the theta which will be required, theta will be the angle of the rebound. In this case, it is 90 degrees. So, like this readings we will calculate the theoretical discharge and we also got the actual discharge. So now the main aim of this experiment is to measure the coefficient of discharge, which is the ratio of actual discharge of water to the theoretical discharge of water. CD is necessary because in the practical applications like canals and rivers, we will not be able to measure the actual flow rate or volume. So therefore, by theoretical discharge formula, that is theoretical discharge of water, and by getting various CDs and getting the average of readings, we will be able to calculate the actual discharge of water in practical applications. So in this case, by getting actual discharge and theoretical discharge, we will get the ratio. That is actual discharge by theoretical discharge, and then that ratio will be our coefficient of discharge, which will indicate the losses incurred in this experiment of flow rate. So this was the experiment of measuring the flow rate to a rebound. This is a very useful experiment which is used in very much applications like rivers and canals in villages or certain rivers or etc. So thank you. I hope my English was not so better because it has difficulty, but I hope the video will be helpful for you for your future studies. And thank you everyone.